Scientists have confirmed that an alien ocean has been hiding beneath a frozen moon for billions of years. And when researchers went back through data collected by a spacecraft that actually flew through material erupting from that ocean, they found something remarkable: a rich collection of complex organic molecules. The moon is Enceladus, a tiny world orbiting Saturn. It may be one of the most promising places in the solar system to search for life. Enceladus was discovered in 1789 by British astronomer William Herschel, the same astronomer who discovered Uranus. For almost 2 centuries, it appeared to be nothing more than another small moon of Saturn. Then Voyager 1 and Voyager 2 visited the Saturn system in 1980 and 1981. Their images revealed that Enceladus was almost completely covered in bright water ice. The surface reflects an extraordinary amount of sunlight, making Enceladus one of the most reflective objects in the solar system. Its surface is also incredibly cold, with temperatures reaching roughly 200 degrees Celsius. By all appearances, Enceladus should have been a frozen, inactive world. But there was a problem. Large parts of Enceladus were covered with ancient impact craters, while the southern polar region looked surprisingly young and smooth. Something had erased much of the geological history there. Then scientists noticed another clue. Voyager images contained evidence that material might be escaping from Enceladus. The mystery would eventually be solved by NASA's Cassini spacecraft. Cassini was launched in 1997 by NASA, ESA, and the Italian Space Agency. It arrived at Saturn in 2004 and began studying the planet, its rings, and its moons in extraordinary detail. In 2005, Cassini made observations that changed everything. Near Enceladus's south pole, the spacecraft detected enormous plumes of water vapor and icy particles shooting hundreds of kilometers into space. These were not simple clouds of dust. They were evidence that material from beneath the surface was escaping through enormous fractures in the ice. Scientists called the 4 major fractures the tiger stripes. The region around these fractures was also much warmer than the surrounding surface. While most of Enceladus was brutally cold, the tiger stripes showed significant thermal activity. Something beneath the ice was producing heat. And something was actively happening inside this tiny moon right now. The plumes also helped explain why the southern hemisphere looked so young. Some of the material falling back onto the surface continually resurfaced the region, while other particles escaped into orbit and helped replenish Saturn's faint E-rain. But the biggest question remained. Where was the water coming from? And what was inside it? Cassini eventually provided an extraordinary answer. Scientists deliberately flew the spacecraft through Enceladus's plumes, allowing its instruments to sample material escaping from beneath the icy crust. The spacecraft detected water, salts, organic molecules, molecular hydrogen, silica particles, and other compounds. The molecular hydrogen was especially interesting because one possible source is chemical reactions between water and rock at the ocean floor. On Earth, similar chemical reactions occur around hydrothermal systems, where microorganisms can use chemical energy without sunlight. Cassini also detected organic compounds in the plume material. Organic does not automatically mean biological. Organic molecules can form through completely non-biological chemistry. But their presence showed that Enceladus possesses the raw chemical ingredients needed for increasingly complex chemistry. Scientists also found evidence consistent with hydrothermal activity at the bottom of the ocean. That changed the question. Enceladus was no longer simply an icy moon with water. It appeared to have a liquid ocean, a rocky seafloor, chemical energy, and active organic chemistry. So how can a moon this small remain warm enough to maintain liquid water? The answer is gravity. Enceladus is locked in an orbital resonance with another Saturnian moon, Dione. Their gravitational interaction helps keep Enceladus's orbit slightly eccentric rather than perfectly circular. As Enceladus moves around Saturn, its interior is repeatedly stretched and squeezed. That deformation creates friction. The friction generates heat. This process is called tidal heating. The result is one of the strangest environments in the solar system. A tiny frozen moon with an ocean hidden beneath its ice and enough internal energy to keep water liquid. And this is where the story becomes even more interesting. Researchers have continued analyzing Cassini's data long after the spacecraft's mission ended. In 2025, scientists revisited measurements from Cassini's close encounters with Enceladus and identified a remarkably diverse collection of organic compounds in freshly sampled plume particles. The material had been ejected from the Moon only shortly before Cassini encountered it. Among the detected compounds were families of molecules including aromatic compounds, ethers, esters, and other complex organics. That does not prove life exists on Enceladus. But it demonstrates that the Moon's subsurface environment is chemically much more complicated than scientists once imagined. And there is an important complication. Not every organic molecule detected near Enceladus necessarily comes from the ocean. Radiation interacting with material on the surface can also create organic compounds. Some researchers have demonstrated that energetic radiation can produce molecules and molecular precursors relevant to prebiotic chemistry. That means scientists have to carefully determine which molecules originate inside the ocean and which can form on the surface. But even this complication makes Enceladus more interesting. Because the Moon appears to have multiple chemical pathways capable of producing increasingly complex molecules. The most important point is that Enceladus appears to satisfy several of the conditions scientists consider important for habitability. There is liquid water. There is carbon-based chemistry. There are other essential elements, including hydrogen, oxygen, nitrogen, phosphorus, and sulfur. There is a rocky seafloor. There is evidence for chemical energy. And there appears to be active interaction between water and rock. That combination makes Enceladus one of the strongest candidates in our solar system for a world that could potentially support life. But there is a critical distinction. Habitable does not mean inhabited. We have not detected extraterrestrial life on Enceladus. Cassini was not designed as a dedicated life detection mission. Its instruments were built to study the Saturn system, not to provide definitive proof of biology. That is why future missions could be so important. A spacecraft specifically designed for Enceladus could carry instruments optimized for detecting complex organic chemistry, biological molecules, cellular structures, and chemical patterns that would be difficult to explain through ordinary geology alone. Scientists could search for amino acids and other potential biosignatures. They could investigate molecular chirality, because biological systems on Earth strongly favor certain molecular orientations. They could also examine fresh plume material before it becomes heavily altered by the surrounding space environment. And the most exciting part is that Enceladus does not require scientists to drill through kilometers of ice to sample its ocean. The ocean is already sending material into space. Every time one of those plumes erupts, material from the hidden environment below becomes accessible to a passing spacecraft. It is almost as if Enceladus has built its own natural sample delivery system. That makes this tiny moon extraordinarily valuable scientifically. Imagine discovering that life exists beneath an alien ocean around Saturn. It would mean that life did not emerge only once on Earth. It would mean biology can arise in an environment completely isolated from our planet, beneath kilometers of ice, powered not by sunlight but by internal chemical and geological energy. That would change our understanding of life itself. But we are not there yet. The evidence tells us that Enceladus is habitable. The chemistry is active. The ocean is real. The energy sources are real. The organic molecules are real. What we still do not know is whether biology is hiding among them. That is the question future exploration must answer. Enceladus is a tiny frozen moon roughly 500 kilometers across, orbiting more than 1 billion kilometers from Earth. Yet beneath its cracked surface may be an ocean with the chemistry, energy, and stability required for life. For decades, humanity looked at Enceladus and saw a frozen point of light. Cassini changed that forever. Now we know that beneath the ice is a world that is still active, still evolving, and still sending pieces of itself into space. The next spacecraft will not simply be visiting another moon. It could be searching for the answer to one of the oldest questions humanity has ever asked. Are we alone? And if life is there, Enceladus may be the place where we find it.